So in the previous video, we have seen the functional block diagram of both your astable and monostable multivibrator and the working principle of monostable multivibrator. Okay. So today we will see the working principle of astable multivibrator. So this is the functional block diagram which we have designed in the case of astable multivibrator. Okay. So what is the working principle? So just like that of your monostable multivibrator, the working principle of astable multivibrator. So what happens, let us consider the first case, initial condition. Okay, so in initial condition, you are assuming that your output V0 is equal to 0. Okay, so I can tell that. So in the case of astable multivibrator, what is your output? Your output will contain both on as well as off state, because it doesn't have any stable state. It is not stable, it is quasi-stable state. So this will be your on time, right, T on, and this will be your off time, T off. Okay, T off. So your time period, total time period T will be equal to the summation of both your T on as well as your T off. Okay, so T off. You have to derive the expression for your T on and T off also. So let us consider the case 1. The derivation for means the working principle of your T on condition. So on time operation. So first condition is on time operation. Okay. So let us assume that initially at time, if this is your time T0, at T0, what will happen to your output? You are assuming that at time T is equal to 0, your capacitor voltage is equal to 0. Because why? What is the reason? At time T is equal to 0, you are assuming that your V out is also equal to 0. Your V out is equal to 0. So if your V out is equal to 0, what will be happening to your Q will be equal to 1. Only then Q bar will be your output, right? When Q is equal to 1, what will happen to your transistor? As we have seen in the previous video, the transistor will be on. When the transmitter is on, it will be acting as a short circuit, okay? So the capacitor will be discharging towards your ground, okay? So when this is on, okay, when this 7th pin is on, your capacitor will be acting as a short and it will discharge. That's why you have VC is equal to 0. But you know that this VC, this capacitor voltage VC will control both your threshold as well as your trigger pin. See, in this case, both your second pin and 6th pin is shorted. Okay. So this control voltage VC, this is your control voltage VC. The connection is going to both your upper comparator as well as your lower comparator. So here, as your VC is getting discharged, when it, you know that this is 1 by 3 VCC. One, it is dropping below this 1 by 3 VCC. Okay, when it is less than 1 by 3 VCC, it triggers your lower comparator and now R will be equal to 1. So output of the lower comparator will be equal to 1, R will be equal to 1. If R is equal to 1, it will switch your Q to your 0. Okay, so the condition here is, till here it is your VC will be controlling both your threshold, but in this case the VC controls the threshold as well as your trigger. Okay, so as it is discharging towards your 0, but when VC is becoming less than 1 by 3 VCC, what will happen? Your lower comparator will get triggered. Okay, so your output will be equal to lower output of the lower comparator will be equal to 1. Instead, what it will become, R will be equal to 1. When R is equal to 1, you know that as per the truth table, Q will be equal to 0. When Q is equal to 0, what will happen to your transistor? Okay, transistor will be going to your off state. At the same time, what will be happening to your V out? V out will switch from off state to your on state. Okay, so this is what happening. So let me explain this operation once again by means of the diagram. When T is equal to 1 and T is equal to 0, initial condition, you are assuming that the output is equal to 0. When output is equal to 0, actually what is happening, your output of the flip-flop will be equal to 1. So when Q is equal to 1, it will drive your transistor to saturation, means what, it is shorted. So you will be having your capacitor to be discharged. It will be acting as a short circuit. The capacitor starts discharging towards your 0. But your capacitor is controlling both your trigger input as well as your threshold input. When the capacitor voltage drops below 1 by 3 VCC, it triggers your lower comparator. Lower comparator output will be 1. In turn, R will be equal to 1, which in turn will make your Q is equal to 0. When Q is equal to 0, automatically it makes your transistor to be off condition. So the capacitor, as soon as the transistor is off, the capacitor starts charging towards your VCC. But as it charges towards your VCC, so once this value becomes greater than 2 by 3 VCC, right here it is 2 by 3 VCC. So once your capacitor voltage is exceeding your 2 by 3 VCC, what will happen? Your upper comparator will get triggered. Now output of your upper comparator will become 1, S will be equal to 1. So when S is equal to 1, Q will go back to your 1. Okay. When S is equal to 1, Q will become 1. So now in the next condition, when Q is equal to 1, what will happen? Your transistor will be on. Once it is on, the capacitor will start to discharge again. Till 2 by 3 VCC, your time will be in the on state. Okay. It will be T on state. The output will be in the T on. So once your V out is greater than 2 by 3 VCC, what will happen? The switching happens. Now your upper comparator will get triggered. What will happen to the output? S will be equal to 1. So if S is equal to 1, your output of the flip-flop will automatically become 1. Then what will happen to your transistor? Transistor will go again to your on condition. When transistor is in the on condition, now the capacitor will start discharging. So as it discharges towards 0, what will happen? When the capacitor voltage becomes equal to 1 by 3 VCC, when it is greater than 1 by 3 VCC, again it will trigger your lower comparator. Lower comparator will get triggered. So ultimately what is happening? The capacitor will be charging in and around from 1 by 3 VCC to 2 by 3 VCC. And this switching action will be done continuously. That's why it is called by another name. It is a square wave generator, or it is a relaxation oscillator. So your total output will be equal to, time period will be equal to, so the total time period will be equal to T on plus T off, which is nothing but equal to T is equal to T on is nothing but charging time plus T off will be your discharging time. So this is your equation. So now if I give the waveform, so what will be your waveform? So let me consider capacitor voltage or capacitor voltage VC. Okay, so what will happen to your capacitor voltage VC? It will be charging from 1 by 3 VCC to your 2 by 3 VCC, right? Time. So this will be your 2 by 3 VCC and this will be your 1 by 3 VCC. Okay, so what will be your corresponding output? Corresponding output V out will be equal to, so when it is starting when it starts to charge, your output will be high. It will be maintaining in the high. So once it reaches your T on is over, it will switch to your off state. So this will be your off state. Discharging. After discharging, again it will go on to your on state. So during discharging, it will be in your off state. So this is how you will be getting your output. Okay, so this will be your T on and this time is going, discharging time is going to be your T off. That's how you will be getting the total time period. T will be equal to T on plus T off. So the expression for your time, that is T is equal to charging plus discharge time, is given by two different steps. Okay, so first is your charging period. We are going to calculate the T on or your charging time TC. Then you are going to proceed with your discharging time TD. Okay, so for in the first case, we have to start with your charging time period. So this will be your charging period. So you know that in general, as we have seen in the monostable multivibrator, the voltage across the capacitor. So VC is the voltage across the capacitor is given by Vc is equal to Vf plus Vi minus Vf into e power minus t divided by Rc. So what is your Vf? Vf is your final voltage, Vi is the initial voltage during capacitor charging, and what is your Vc? The capacitor voltage during the charging time. Now what will be your T in this case? T will be equal to your charging time, right? Tc. And what will be your R? R is your charging path. So what will be your charging path? Charging path is through RB, RA towards Vc. So it will be, the path will be RA plus RB into C. Whereas your discharging path will be towards the ground. It will be through RB alone, RB into C, right? So here in this case, let us replace this R by RA plus RB. Okay. Now what will be your initial voltage? Vi is equal to, so the charging time period, let me write it towards your side. What is your charging time period? Charging is from 1 by 3 VCC to 2 by 3 VCC, right? So ending is 2 by 3 VCC. It can charge towards your 0. So your VF will be, Vi will be equal to initial charging instant 1 by 3 VCC. Now what will be your VF? VF, it is charging towards your final value, that is towards your VCC, right? It can charge towards your VCC. Vf. Now what will be your Vc? Vc will be equal to 2 by 3 VCC. So Vc will be the voltage at the end of the charging time. Okay. So when you substitute all these values, now T should be replaced by charging time, and your R will be replaced by RA plus RB. These are the variations you are going to substitute here. So what will be your equation now? So your equation will be modified to Vc is equal to 2 by 3 VCC, right? 2 by 3 VCC, which is equal to Vf is equal to, what is the final value? VCC plus what will be your initial value? 1 by 3 VCC minus your final value is again VCC into minus Tc divided by Ra plus Rb into C. Okay. So this is the equation you are getting. Now what will be your equation now? 2 by 3 VCC will be equal to VCC plus here 1 by 3 VCC minus VCC. So what will be your value? It will be minus 2 by 3 VCC, right? Minus 2 by 3 VCC into e power minus Tc divided by Ra plus Rb into C. Okay. So this will be your value. What will be your next step? 2 by 3 VCC is equal to VCC plus VCC. So minus 2 by 3 VCC into e power minus Tc divided by Ra plus Rb into C. Okay. So here you have, I can take VCC as common, right? So 2 by 3 VCC is equal to, if I take VCC as common, what will you get? 1 minus 2 by 3 into e power minus Tc divided by Ra plus Rb into C. VCC will get cancelled, right? So what is the value you are getting? 2 by 3. 2 by 3 is equal to 1 minus 2 by 3 into e power minus Tc divided by Ra plus Rb into C. So if I can take this 1 towards the side, then what will be your value? If I can just reconfigure it, 1 minus 2 by 3 is equal to, this minus goes off, 2 by 3 into e power minus Tc divided by Ra plus Rb into C, right? So what will be your value? 1 minus 2 by 3 will be equal to 1 by 3, which is equal to 2 by 3 into e power minus Tc divided by Ra plus Rb into C, right? So 3 will get cancelled. Now what is the value you are getting? 2 into e power minus Tc divided by Ra plus Rb into C is equal to 1. So if I take this 1 here, you will be getting it as 1 by 2, right? So e power minus Tc divided by Ra plus Rb into C is equal to 1 by 2. So it is looking like the equation, just like the equation e power k is equal to C, right? So what will be your value? So what will be your K? K will be equal to ln C, which we have seen in monostable multivibrator, right? So if you rewrite this equation, so what will be your T? T is equal to, in this case it is T is equal to minus TC divided by RA plus RB into C, which is equal to K is equal to ln C. C is equal to 1 by 2. So you know that log reciprocal theorem. You can write that. What was your theorem? Ln 1 by 2. Sorry, 1 by x is equal to minus ln x, right? So when you replace this by the formula, you will be getting TC divided by RA plus RB into C, which is equal to minus ln of x. X is equal to, in this case it is 2. So minus minus will get cancelled. So your charging time will be equivalent to RA plus RB into C into ln 2. So now what is the value for your ln 2? The ln 2 will be equivalent to 0.693. Okay, so TC is equal to 0.693 into RA plus RB into C. So this is going to be your charging time. So now we are going to proceed with the second step, that is during the discharging. What will be your condition? Okay, so during the discharging you have the same formula. Vc is equal to Vf into Vi minus Vf into e power minus t divided by Rc. Now what are the values you are going to replace? Your discharging time period is from what to what? So 2 by 3 to 1 by 3 VCC. Sorry, 2 by 3 VCC to 1 by 3 VCC. So your charging ends at 1 by 3 VCC. So what are the different values you will get? Vc will be equal to 1 by 3 VCC, right? Now Vf will be your final value. So in this case the capacitor can discharge till your 0. So Vf will be equal to 0. Okay. So what will be your Vi? Vi is equal to discharging starts from 2 by 3 VCC. Okay. So these are the different values which you have. Now then what is your T? T will be replaced by, small t will be replaced by discharge time Td, and what will be your discharge path through Rb, right? So R will be replaced by your Rb. So these are the modifications which you are going to do in your expression. Okay, so what will be the value you will be getting? So I can write that Vc will be equal to, let me write it here, Vc will be equal to Vf into Vi minus Vf into e power minus t divided by Rc. Now I am going to substitute all the values. Vc is equal to 1 by 3 Vcc, which is equal to Vf is equal to 0, right? 0, it is plus here, right? So plus, okay, 0 plus, what is your Vi? Vi is equal to 2 by 3 Vcc minus, what is your Vf? Again 0 into e power minus t will be replaced by Td, and R will be replaced by Rb into C. Okay, R will be replaced by Rb. So now what will be your equation? So 1 by 3 Vcc will be equal to 2 by 3 Vcc into e power minus Td divided by Rb into C. So Vcc get cancelled, 3 get cancelled. So you will be getting 2 power minus Td divided by Rb into C is equal to 1. So e power minus Td divided by Rb into C, I have taken the 1 towards the other side, so 1 by 2. So it is looking like e power k is equal to C, right? So k will be equal to what? Td, k is Rb into C, which will be equivalent to your ln C. That is nothing but ln 1 by 2. Okay. So here minus Td divided by Rb into C, by log reciprocal theorem, you can write log 1 by 2 as minus ln 2, right? Now minus minus get cancelled. So what will be your value? Rb, I am taking, sorry, Td, I am taking Rb into C the other side. So Rb into C into ln 2. So now what will be your value? Td will be equal to Rb into C into 0.693. So I can write that Td is equal to 0.693 into Rb into C. Okay, so now what will be the total time period? So the total time period T is equal to Tc plus Td. So what is your Tc? Tc is equal to 0.693 into 0.693 into Ra plus Rb into C, plus what is your value here? Discharge time 0.693 into Rb into C. So if I can take 0.693 as common, right? Here it is Rb into C. So you can write it as 0.693 into, so what will be your value you are getting? Ra plus 2Rb, right? 2Rb into C. So your T will be equal to 0.693 into Ra plus 2 Rb into C. Now your free running oscillator is called as free running oscillator. So your frequency of oscillation F is equal to 1 by T, right? So if I can take F is equal to 1 by, substitute the value for T, 1 by 0.693 into Ra plus 2 Rb into C. So what is 1 by 0.693, which is equal to 1.44 divided by Ra plus 2 Rb into C. So this will be your expression of your frequency. Okay.